Okay, today, the new lesson, this is chapter 4 now, is about graphing. And today we only have to get through two concepts. Basically, increasing and decreasing, which is pretty easy. And then the other one is odd and even functions. And that's a lot like x-axis symmetry and y-axis symmetry. Do you remember those symmetry tests that we did before? Okay, we had a test for x or y, or what was the third kind? Start with an O. Origin symmetry. Remember those? Okay, so here is increasing, decreasing, and constant. Those are three things that a graph can be doing over time. Imagine that the x-axis is time. In this case, it wouldn't make that much sense because we have some negative time, but you can actually think about negative time in terms of back in time from now. All right, so increasing, I think we all know from here to here it's increasing. But how do we say that? You say it with an interval. Okay, so everybody put in a parentheses like this, and I know we could argue about whether it's brackets or parentheses. We're going to keep it simple and just use parentheses. It's increasing between -6 and 1. People get confused on that because they're like, well, that doesn't say how high it goes. You know, it only goes to 3. That's different. That's when you're talking about maximums and minimums. That's when you use that terminology. Here we're just saying from here to here, it's increasing. And what are those spots? -6 and 1. See, it's the x values over which it is increasing. Yes? I was saying before that we could argue about whether or not it's brackets or parentheses, but we're going to go with parentheses. There is some esoteric arguments about, is it increasing once it stopped? Once it stopped increasing, is it still increasing at that moment that it stops? Well, right up until that moment it was increasing, but don't you need that last point to be able to say it was increasing to that point? So again, I actually know that there's different textbooks that use brackets, and there's other textbooks that use parentheses. So you can obviously have a debate about it, but I'm going to go with parentheses. If you use brackets for increasing or decreasing, I won't even mark it wrong. Okay? Decreasing. Obviously, this section here is decreasing, but how do we say it? Would you please write it and be careful? That's a 7 at the end there in case it's hard to read. Did you say it was decreasing from 4 to infinity? If so, you were thinking there was an arrow at the end of this. There's not. It doesn't have arrows at the end, so we can only say with confidence that it's decreasing until it hits 7. Again, I really don't mind if you put brackets, but I'm going to use parentheses. And constant. Constant is where it was not moving up or down, and that was between 1 and 4. 1 to 4. Raise your hand if you feel comfortable with increasing and decreasing and constant. Good, that's pretty easy. It's just, remember, it's the x numbers. These are all x's, and people look at that and think it's like a y. No, this is an interval from the x is 4 to x is 7. Okay. Now, I know this is strange, but erase all of those because your homework, this is actually your first homework question. Your homework is not to do this one because we already just did it in class, but to do this one. Now, I need to give you a few points on it to know where its highest and lowest spots are and stuff. Right there, we're going to say, which is at 1, 2, 3, 4, 5, -5, comma 5. Better write this down because you'll need these points. That's the highest spot around, and we're going to say the lowest spot in this neighborhood is at 1, comma -5. And then we're going to say it reaches its peak right there at 5, comma 7. Right now, you could already be filling in your first homework answers, which are increasing, decreasing, or constant in this blue graph down here. Okay. Then what about local mins and maxes and absolute mins and maxes? Locally, let's say you're the strongest kid in this room. Let's say we have an arm wrestling contest and some kid wins. Okay? Then locally, he's the strongest. Does that mean he's the strongest in the whole world? No. But is there a strongest kid your age in the whole world? Yes. We could figure out who that was, and then that would be the crowned the strongest of them all. People get confused about this because they think that only one of these two can be a maximum. No, they're both locally, like the strongest kid. Locally, they're the highest point. So those are local maximums. But only one of them can be the what? Absolute maximum. Okay? So of those two, of course, the absolute maximum is at this point. All right. So let's move on to, I hope that that's pretty self-explanatory. There's 3 points that we highlighted there. There's 2 maxes and there's 1 min, and that 1 min does appear. Oh, here's another thing that people question. If there's only 1 minimum, like there is, and it is the lowest of all, is it both a local minimum and an absolute minimum? Like, let me ask the question this way. Let's say with a kid in the room, and he was the strongest in this room, and he was the strongest of all people in the whole world. Would he be locally the strongest? Yes. And would he be the absolute strongest? Yes. You can be both. A point can be both a local minimum and an absolute minimum or maximum. Okay, we're done with that. Now, the next topic to learn is about odd and even. And I'm going to give you a nice little picture for even symmetry. Even symmetry. That has got even symmetry. Does that look familiar? We didn't call it even symmetry before. We called it what? Y-axis symmetry. So they're the same thing. See? It says right here, same as y-axis symmetry. All right? So if I give you this picture, I did it terribly. I'm going to try again. It's an absolute value that's been flipped upside down. Would that have even symmetry? All right. So would that be an even function? Yes. Even functions look like this and this. Okay? Odd functions have origin symmetry. Do you remember origin symmetry? It's the kind that where you have a dot, let's say here, you go through the origin and out the other side, and there better be a dot there that matches up with it. Now, I didn't draw that perfectly, so it's not matching perfectly, but that's supposed to be an example of an odd function. And odd functions have origin symmetry. So this spot here goes through the origin, comes out the other side, hits another spot there. Origin symmetry. But what you're going to want to memorize for these are the last little statement in each of these little boxes. F of negative x will equal f of x. And f of negative x will equal negative f of x. If it's even, it looks like this. If it's odd, it looks like this. And if it's neither, then it doesn't have either one. That's pretty simple. Neither is just not odd and not even. Okay, so what does this really mean, this f of negative x thing? F of negative x is equal to f of x. That's the even one. Maybe you want to write these down on a separate sheet so that you can try to start memorizing them, like off to the side or add a page, but write them down with your own handwriting. That'll help you remember it. And the odd one, you'll notice, is a lot alike. Notice it starts with f of negative x, and it also has an f of x in it. If they were this way, it would be identical. So what's the difference? A negative. And you can say, oh, it's got negatives on both sides. That's odd. Dumb things like that can help you remember it. So, all right, so what do we do to prove something is odd or even? Let's say I had this. And I said, is that odd or even? Now, your gut feeling might be, oh, I think it's even because it's got a 2 in the power. You'd be wrong. You can't just assume that. Just because it's got a 2 here does not mean it's going to be even. Okay? And just if there was a 3 there, you could not assume it's odd. What you have to do to tell if it really is even or it really is odd is you figure out f of negative x. And if f of negative x, once you drop in a negative x, comes out exactly the same as f of x did, then you've got an even function. So I'll show you that. Let's say I was going to drop in 2 empty spot negative x squared plus 2 empty spot negative x. When I actually multiply this out, I get the negative x squared is going to come out back to 2x squared again. But this one comes out to negative 2x. Is f of negative x, which is what I just figured out there, is this exactly equal to that? No, it's off a smidge, so it's not even. Does that mean it's automatically odd? No. We got to do the odd, I'm sorry, this is the odd, what I have written above it here is the odd test. I was testing for evenness, sorry. The black one here is the even rule. So, there. Did f of negative x come out to f of x? No, it did not. That was what I was testing first. Now I can test and see f of negative x. If this was really odd, then f of negative x would equal negative f of x. So let's test that. Part of the beauty of this is we've already tested f of negative x. We already know it. F of negative x came out right here. So I can just say, oh, so you're saying 2x squared minus 2x should equal negative f of x. Negative, parentheses, dropping in f of x. F of x is this guy. And then I drop in this right there. And I have 2x squared plus 2x. Now, look at the statement I just wrote. Is that true or is that not true? Do they come out exactly the same or not? No, they do not. Because once I distribute this negative to both parts, it'll have a negative 2x squared and a negative 2x, and that's not the same as this. So therefore, no. Therefore, not odd. So I just proved that this little function right here, it is not even. I tested that first, and then I proved it was not odd. Therefore, what is it? All right. Even, odd, and neither. You've learned one of your next topics for your next test. We'll practice it, but even functions have to follow this rule. Odd functions have to follow this rule. And in either case, you're just comparing things to f of negative x. You drop in a negative x into the function and then see how it comes out. Okay, and then picture-wise, just really quick and easy. If drawn with perfect accuracy, does that look like it would have even symmetry? No. Does it look like it have odd symmetry? Yes, because it has origin symmetry. And it's therefore can't be a neither, because it's already been chosen to be an odd. All right. Now increasing and decreasing was the other topic. So if you saw something like this, what's that spot called? Local min. What's that spot called? Local max. As opposed to local moco. You know what that is? It's in Hawaii. It's a favorite dish of the locals. You start with rice. You put down 2 patties of meat, like from a hamburger, and then you have 2 fried eggs on top of that. That's loco moco. Actually pretty good. All right, anyway. Local, maximum, local, minimum. And the way I drew this thing, going on forever like this, does it have a maximum? Does it have a max, an absolute max? No, because it just keeps going. And you should not say that the maximum is infinity, because otherwise you're implying that there is a highest spot on this graph. There isn't. There is no absolute max, and there is no absolute min. What is it doing in this little zone right here? Decreasing. And if I knew the x values of these points, let's say I pick this as -1, 4, and this is 3, 2, you would say it's decreasing. Do you use the x's or the y's for this? The x's. So you'd say from -1 to 3. It's decreasing. That's a summary of what you're supposed to know for today. Pretty easy day. So let's see what your homework is. I said on this part, I would like you to answer all of these questions right here for this graph right here. Tell me where it's increasing, where it's decreasing, where it's constant, and there's no place it's constant, by the way. And then local maxes and mins and absolute maxes and mins. And for these, you can just list points for me. This point is a local maximum. This point is a local minimum. Yes? Yes, well, actually, you should say none, because leaving it blank implies I don't know what the answer to this one is. If you think the answer is no solution, you should write no solution. Yes? I would prefer that you just try this tonight. I think you can do this. It's not super hard. We're just answering these 1, 2, 3, 4, 5, 6, 7 questions. And then on the next page, these were ones that I've already done enough on in class. So your actual homework starts right here. I would like you to do 1, 3, and 8. Then we're going to skip a few because we don't have as much time as I would like. And the next ones we do are all of these. All of these. Even if they aren't circled on yours, all of them. They are not hard. They are easy. Every single one of them is a review of algebra stuff. Like the very first one. What's the range? You've been doing domain and range since the beginning, right? The range is from here to here, from the lowest to the highest. Later you're going to be asked what's the domain of it. You'll be asked things like what's f of -2? That means they gave you x is -2. Okay, how about this one? They're giving you not x. What are they giving you? Y. They're giving you y is 4. F of x is like y, right? So y is 4. If y is 4, you make a line across here and go, oh, that must be the spot you're talking about. And you just tell what the x is. List the y-intercepts. If you can't find the y-intercept, I am scared for you in this class. The f of x is greater than or equal to 0. That is like y. Don't forget that's like y is bigger than 0. Where's y bigger than 0? There and there. How would I say those? In interval notation. So how is it? Where is it above 0? From there to there. And the other part. I don't want to answer your whole homework assignment here, but this yellow page is assigned. I want you to do them. They're all very doable. Okay, now we have plenty of time left to still finish our top 20 today. And you'll have 20 minutes to do that. And then after that, we'll be putting it into Schoology. At the end, that can be a stressful part for some people because they don't want to get it marked wrong just because how they typed it in. I agree, that can be stressful. Now, you do need to follow the directions on typing that in. I guess that's all I have for the lesson for today.